So while it's happening, Madam Chair, thank you very much, Michael Lucan, Wage and Lee, and Carol Grash for inviting me, giving me the opportunity to actually talk to you and present some interesting topic that is of serious interest to me. We lost the slide actually completely now. I can't see the slide. It's coming back. Okay. So I will be able to operate with what we see now. So the object is to talk to you about data. Data, however, that are static are not very useful, so we need communications. Then, but communications and data are not good if the data are not very good. So collection of good data is important, and all of that is essential then to do something that is related to everything we've been talking so far. It's helping in the operation of various devices and systems to make the life in the Arctic sustainable. My background is in computer engineering, computer science. I've been doing a lot of work in signal processing to establish the first microelectronics center in Canada. I live in the center of Canada, University of Manitoba, where we are doing some work related to collecting data, transmitting them, making sense of the data, and doing teleoperation through cognitive digital twins that I want to mention several times during our talk. I also been active in IEEE. I was the director, Region 7 director, but so is Micah. I was also vice president of IEEE educational activities. She was obviously much bigger vice president because she was vice president of MGA. So I think we're both coming from the sense of IEEE is a very beautiful organization, but are we doing enough for solutions that are very urgent? As you have seen and heard from Wage and Lee, IEEE is doing a lot, and I want to really contribute to a little bit more to saying it. How it can be done, what can be done through satellites. Next slide, please. Could you advance to the next? Thank you. So the talk will have 3 parts. The fourth part, Micah will like it, is call for action. And the action will be very specific. So the motivation is that for me, Arctic is a treasure and is irreplaceable. We have to help in that to continue. We have now satellites that can be combined with the terrestrial networks to do the collection and real-time or near real-time operations, including the Arctic. That was not very feasible in not too distant future, past. And then I want to really show you how many of the projects that were mentioned yesterday and today could be helped through those activities too. Then the second part will be showing you how that bridging could be done and how we are doing it. And then the third part is showing how we could really do it not alone, but while doing it, preparing the next generation of people, as we heard, responsible, confident, and also competent to achieve those goals. Next slide, please. So the Arctic is too vast and too harsh to collect data, analyze, distribute them on the ground alone. And we need a little bit more eyes, and the eyes will have to be a little bit higher, and eyes that would see not only during a day, but would see in all of the frequencies and all of the also day and night. Next, please. Next slide. So as you see over here, the circle of the Arctic Circle includes not only Canada and the United States, but also Russia, Finland, Greenland and other places, and many indigenous people speaking many languages with having different cultures, as my colleague from Montreal indicated, for whom the land and the environment are extremely important. It also has unbelievably unique wildlife that also requires special attention and is extremely rich in diamonds, gold, platinum, iron, and uranium, many things that might be used in the future for a better use and better purpose. Next slide, please. Then the um, however, the conditions have changed and are changing, so the supply routes and connectivity have to be addressed again because of the changes that have been happening for a while. The marine and transportation opens up, and Russia is building already many ports in the north, thinking that there will be enough water to shorten the routes and do the job faster, but that will lead to many possible complications. The communications and infrastructures also vary very much. For example, we are coming in a year or two to the sunspot peak cycle, that many of the interruptions will happen in satellites and terrestrial. And then when we address all of those things, data will be available, and Rakesh Kumar has been pointing out and developing. We can collect the data, and IEEE can provide services to share the data very effectively, not just as dumb data, but smart data for those solutions to be addressed faster. Next, please. So the activities that we have to address is we already have, so I won't repeat, the monitoring of the Arctic Ocean, monitoring of the permafrost thawing, monitoring of the ice movement to help in navigation, monitoring of the marine and air traffic to look for all sorts of problems, and then looking at the different transformations in the magnetic field and the solar flares on all of the activities that we are, including power generation, including microgrids that we heard so much about. And above all, using those facilities also to help in healthcare and education. Next, please. So the satellites, the traditional satellites in Canada that have been used are RadarSat, that is very good. I contributed to the codec for RadarSat 2, including development of new wavelets with Yves Maillet in France, the father of wavelets, to do specific things that were considered impossible in specific bandwidth that would be available. The RadarSat constellation was built in the place where I live also over here. I don't have the time to show you much about it, but those are fundamental satellites that collect lots of data, high quality data. And there are many other satellites that have been doing beautiful things and are also in development. Next slide, please. But there are also many other satellites altogether from the European Space Agency, obviously the US and other countries that have been involved in doing a lot of data collection. There are 11 sea ice variables listed in this specific Sankey diagram, and they're listed over here, and also many other satellites that are being developed that are monitoring the sea ice. These data are available and can be used for many activities already. And obviously the future will bring more. Next slide, please. Another Sankey diagram shows the monitoring of the ocean. Again, many parameters are being collected. As you can see, this is not something that will be happening in the future. It is happening now and will be continuing with more and smarter components. So that enormous level of data has to be stored, has to be pre-processed, has to be verified, has to be cleaned up. IEEE now has the ability to also help in that process too. And many of you who are collecting data also from terrestrial, through terrestrial means should consider that too. Next, please. So all of the issues that are related over here are somewhat very much related to what you've been talking about. The need to do it more efficiently, more reliably, more sustainability, in a more sustainable fashion, and also doing it not only with people who might not be able to do it, but remotely. So this specific talk is very much related to all of the other resilience of energy sector, the microgrid technologies, microgrid operations in the Arctic, and the technologies for diesel use reduction, and then other components that we heard yesterday and will hear now at this conference. But there are also other issues that ought to be considered too. The internet and other connectivities must be considered. Cyber physical security, I have not heard almost anything about it so far. I think is absolutely critical. I lived in a place where in January, if someone will attack our grid and our power, we probably survive 1 week at the most. Most of us will die in 3 days. So this is of paramount importance. We have to know how to protect ourselves, and now the availability of satellites may somewhat help in that process. Then navigation and new transportation modes. We are developing new airships, no longer helium but hydrogen, that could deliver facilities, but that requires also navigation in environments where GPS may fail too. So we have to develop new abilities to do so, and new experiential education will bring the new generation of people who could become competent. And competent in what? Not just to operate diesel generators or the small factor nuclear reactors, but develop new abilities to mimic those things and operate not only locally, but also see that the planet is one, and we shouldn't be operating it from any other place on the planet. That will require also the sky to participate. Next slide, please. And as Mike mentioned yesterday, the product cycle can also be addressed through that teleoperations in real time. And that is an important component in it. It is not only the end of life, but end of cycles and multiple recycling. So this is what is possible today to a great extent. The idea is how to move it beyond what is just roughly possible, but how to use it and implement it. Next, please. So in the second part of it, I would like to show you how the real-time teleoperations could be done using terrestrial and non-terrestrial networks together. Next. So the fact that I can really talk to you at a long distance, I live over here, you live over the, you live at the lower left side of the slide, much higher. But if I lived in Europe, I probably couldn't do it through the terrestrial networks only. Next, please. So all of the submarine data highways have been developed, but all of that still is limited to all of the disturbances and activities that have been going on, and all of the attacks that have been going on for a while now. So we have to look at the sky too. Next, please. So the sky has been used now for a while, not only through the through the moon, but also the geostationary satellites for television distribution and various communications, and then the mid-Earth orbit, where there are many activities going on to provide GPS and many other navigational systems. But my interest is the much lower orbit satellites. Next, please. In the much lower orbit satellites, although we have to move the satellites very fast, almost 7.3 kilometers per second, rather than much slower elsewhere, where the satellites are visible only for a few minutes, with the cycle, with the orbit 90 minutes or so, we have now advantages that could not be available anywhere else. In order to do real-time operations, the delay or latency time has to be much shorter. Next, please. So in the area now, this is a simulation of all of the satellites that are in the far orbit, middle orbit, and low Earth orbit. As you can see, they have different orbits, different styles of orbits, and all of them have specific purposes for communications, but also data collection. Next, please. And those satellites utilized ground stations and then distribution networks over here to reach our cell phones, reach cars, and reach various factories to communicate and operate. Next, please. In various different categories of wavelength, we have been moving from the very low frequencies of 2 meters and 70 centimeters to other gigahertz bands. My interests now are in past microelectronics, into plasmonics, into terahertz operations that can do now various things, and to match the optical telecommunications that can be done between satellite constellations. Next, please. So there are fundamental advantages, but look at the first top line, low latency. The 5 to 10 milliseconds is still long. With today's operations and atomic clocks going to picosecond resolutions, this is long, but it's also satisfying many requirements. We can now do real-time or near real-time operations at a distance. Next, please. This picture shows you the dust of satellites that already exist. Next, please. With the one that everybody knows, the International Space Station. It will come back to it later. Next, please. But what I want to show you is what is happening now. The network on the ground has developed as this very beautiful, complex type of networks. Complex means interacting, self-organizing into big nodes and small nodes. This has now started happening also in the sky, because we no longer have a few satellites, but we have thousands of satellites already orbiting in different classes of orbits. Next, please. This is, for example, the satellites that I see at any time. That's where I live over here. I see 14 satellites today, and the satellites move continuously, so I can really choose and operate various things. But you can also see many ground stations that are required to do so. I brought this picture too, because you can see the north is not very well covered yet. Next, please. And in those satellites, you also need ground stations with steerable antennas. This was the old style of Starlink antenna. It was very good for cats that were very cold. This does not have any cats because it's no longer as warm, and it's not only a warmer for animals, but it really is very, very fundamental new tool that we are using in the various ground stations that I will be showing you. Next, please. So those operations now of many satellites and satellites that we are also building require ground stations, a new class of networked ground stations. And there is one ground station network, a low Earth orbit satellites and systems ground station network that is called SatNOGs. And you can see the various parts and various distributions, including some where I live, a few in Alaska. So it is not full coverage, but there is already a start towards better type of networking and connecting the satellites in a smart way. Next, please. This is another network that is related to the Internet of Things and the Thing network that has now 21,000 gateways, and there are 200,000 members that are started interacting, looking at the sky, collecting data, and interacting between the different parts of the world. Since the satellites move very fast, we can only see it 6 minutes really from horizon to horizon. It's too little to collect data, complete data. So we have to pass that satellite to someone else who would be able to receive the next portion and the next portion and have the receiving component of data throughout the day. Next, please. So in order to now achieve the goals, we have to have specific new solutions too, and the new solutions will not be done by new startups alone, will not be done by the existing well-established companies, will require new approaches. So what I will be showing you is looking at the younger generation of people who are looking for problems to be solved, are extremely good, and can participate and learn through the experiential learning, not only the book of knowledge that is we provided, the body of knowledge that we provided when teaching various courses, but experience that can be brought not only to themselves through their own hands and experience, but through very seasoned professionals who can teach them too. Next, please. So the lifelong learning is the key idea behind the next generation of teaching that we hope to do. Next, please. The old style of having one job in a lifetime is gone. We will have to have many. And today we have now 5 generations at work. And those generations will not stay with one work, will have to be retrained. This is a style also, and the challenges that we have to resolve. And what we are talking about is this style and challenge that can be provided to young people and excite them to participate in the solutions. Next, please. With new styles of education that would involve digital twins, personalized digital twins, cognitive digital twins, that also connect with the past and the future, that would be predicted within the horizon of predictability available. Next, please. Just to show you that it's not just words or plans. In 2010, I established a group of 130 students for the purpose of building a new satellite. It was the style of CubeSat, the era of CubeSats. And those students, from 130 students, came from 16 departments. We had 70 advisors. And what you see on the right is the new satellite. Everything was designed from ground up. Those students then went to lead big projects in various aerospace industries because of their experience, because of their knowledge, and the participation of industry selected those who obviously worked very well, who knew how to do it. At the same time, I've been organizing seminars, space camps, and also discovery weeks for indigenous students across Canada and also elsewhere. What you see over here is the teaching and involvement of the students in other projects too. Next, please. Our 6th generation of satellites, now we are in the 6th generation, went into space in June of last year's June, and then was released months later from ISS, the International Space Station, and is functioning with problems, but is functioning. Next, please. In order to, however, continue this, we also, the low Earth orbit satellites and systems, the IEEE initiative, has developed a plan to engage students in research projects and capstone projects, the final year project, with the involvement of industry, to develop many components for those little satellites that can be put in space, but also different classes of smaller satellites, all the way to femtosatellites and attosatellites, that could really be lasting for a shorter time, but it would be much cheaper and could be brought into space at a much lower cost. will be one of the calls for action that I would like us to also connect and start cooperating at least, but then collaborating on those projects in Alaska, in different parts of of our countries, but also South America, Europe, and Africa, and Australia, so that we would become again closer and closer to achieving those goals faster, not eventually, but faster. Next, please. And that involves different classes of engagement. I won't have the time to tell you, but we are talking about space Internet of Things, space edge computing, and space edge compute ecosystem, and then space cloud compute ecosystem too. Those components exist to some extent for very expensive satellites. We would like to reduce it and provide it proper. In order to do that, our LeoSats produce now 5 workshops. One of them was dedicated to edge computing. On Thursday, we had the 5th workshop on various aspects of space environment and sustainability of that environment. The junk can kill us that exists already. We have to eliminate it. We have to also create space that is sustainable. That workshop was attended by 200 people and registered in hundreds more. So I think there is interest in that process. So I'm very encouraged to also talk to you about it, because together we can bring the sky and the ground together to achieve the goals that all of us are dreaming about. Next, please. And we could really plan on specific observations to supplement those observations that are being conducted, as you saw at the beginning of this presentation, by major governments and major companies. Next, please. And the call to action to complete it is to collaborate eventually, but we would start from cooperation between various universities and colleges. As you know, the Arctic Circle created a University of the North. We should revive it. We should revive it with a new perspective for research, and then develop education, experiential education. And then in order to engage the students, so that they could also feel that they matter too in that solution, we could really create competitions. And the experiential learning will last forever. It is not just book knowledge that is often forgotten. It is the practiced knowledge, that body of knowledge that I think we ought to develop. And we need new classes of ground stations that have to be developed. And they won't be developed by the governments. The governments are too busy with other things. We, all of us, have to be engaged. And then, obviously, since Rakesh Kumar is with you, I could not really skip this component. Remember, the data sitting at your desk, on your desk, or in your computer are not very valuable, but they may be gold. This is the new gold that we have to exploit. We have to explore. We have to know how to recover its value. We have to really do it, and that can be done through the IEEE data port. The data port already has 63 competition data sets for the extreme programming competition, signal processing, environmental engineering, machine learning, and many others. Next, please. So the collaboration can engage the activities that are ongoing everywhere, including nuclear reactors. As you know, nuclear reactors do fly also in deep space. I designed memories for self-organizing and self-healing memories for deep space exploration at National Semiconductor in California. I know that it can be done, but in the past there were too few of us. Now we ought to have all of us engaged. The time is ticking. The time is asking us to be more active. Next, please. The competitions, some of them, the extreme programming competition, already has 14,000 people. and it is growing. Many countries are involved. But the point I'm making is that those competition also produce value. There were in the 13th competition a few years ago, there were 500,000 solutions. Some of the solutions are astronomically good. We could share them in industries. We could share them with other universities that don't even know about such solutions that exist and are available to us. Next, please. So the point over here is that if we would do it, we might have a chance to make the difference. All of you and all of the presentations that I attended so far are talking about the need to make a difference, that the old style of operations may not be as good, but we can't just jump. Many of you said we have to be prudent. We have to be careful, because the mistakes will be made and the cost may be greater than not making those mistakes. So in order to help in that process, please join us. Join us, and we could really then talk, and we can really create that new possibility. If you want to, if you send an email to Leo Satz, we would respond and engage. You can volunteer or just get updates on all of the activities that are going on. Next, please. So this is a picture I took on my trip to the north when I organized an expedition to the north for IEEE to show them that we're not talking about gigabits per second transmissions in the north. We are talking about kilobits per second transmissions. We have to improve it. But this is an indication to me, and Inukshuk is, yes, we are explorers. We were here, but we ought to be here for a much longer period of time. And we have to also be able to build such stones too. And next, please. So I would like to thank you, and thank you all of those people who are working in our group, including Marcus Gardil, Jan Budrovite, Peng Hu, Dave Magnani, Grayson Randall, and Carol Grass, who has been helping us in many different ways. But above all, too, Bill Tonti. If you want to ask about the future, what not to do, and what to do, ask Bill. Bill is always right. And the other person I also included over here, Rakesh, is always right. His ability to create things that may last is uncanny. So I would like to thank you all for it. Yeah, we have a long way to go, but we are not afraid of it. We will be growing and taking those steps one by one. The remaining parts of the presentation has references and have also some other things too. Thank you so much. Ready to answer questions, if any.
Thank you very much, Witold. That was formidable, as always. I really I would have liked to have a 2-hour presentation from you. So my apologies for keeping you in half an hour. But thank you very much for keeping the timing as well. So we have coffee served here, and then we'll go into breakout. We will try to have a separate breakout online and one here. So Weijen will take one and I will take the other, I believe. But maybe there's a couple of direct questions for Witold that you would like to ask. Is there any right now? Any online? No, don't see one online. So I think you're off the hook right now, Witold. There will be opportunities later on.
Yes, thank you.
Okay, so we will come back. And oh, there's one from Bill. Bill Tonti is here.
Hi, Witold. Thanks for your great presentation and your nice accolades. So about the future. Yesterday in our discussions, I don't know if you heard, but Weijen piped up and talked about using low Earth orbit satellites, maybe, or some combination of low Earth orbit and essentially interstellar orbit, and talking about coming up with a solution of providing energy capture in space and somehow moving into Earth. So can you help us with that?
Yes, there are many solutions, and that's one of which could really be a solution to the north and the whole planet. Swarms that are self-arranging, are perpendicular to the planet, very far away, always see the sun, and then transmission, a microwave transmission to the planet. There's also so that's my biggest hope. I've been thinking, and we were working on various aspects of the transmission, but also the self-organization and how they can really be self-organizing. If one fails, how they can self-repair. Then what the transmit and the coordination of it. One of the major issue is time coordination. As I mentioned, my former student is a person who developed that PCIe card with an atomic clock over there, and with resolution sub-picosecond resolutions. I'm also working with other people who are developing coordination and also optical propulsion and optical communications for Alpha Centauri trips too, where obviously we won't be able to fix it. They will have to fix themselves. So my interest is the constellations of low Earth orbit satellites to do lots of the work, communication work, and also the edge computing that will have to be used for the self-organization of the big solar panels. That would be able to coordinate themselves, fix themselves, then also communicate with either lower portions or directly with the planet. So this is a fascinating area. So I think that Wei Jian knows a lot about it, but we are looking from the signal processing point of view, from the AI. By the way, we are actually building new AI components and elements, hardware and software, but specifically algorithmic issues now, to make it smaller and push it into the edge. For me, the low Earth orbit satellites that we are building will have to have edge computing of a major caliber.
Okay, thank you very much, Witold. Any other question right now? Okay, so right now I don't see any here. And did you see anyone online? You see a question online? No? Okay.
No.
So thank you very much.